5 times something, and then you're going to say what it equals. Okay, so then you're just going to plug each point in there. So the first one is 4, 4. Now, if you're comfortable doing a little bit of mental math, this won't take as long. If you just look at that, what is 3 times 4? What's 5 times 4? What's 12 plus 20? And then you will do that with each vertices in the problem. Zach, whenever you plugged 1, 1 in there, what'd you get? What was that? 8? Paulina, whenever you plugged 1, 8, what'd you get? And Ryan, whenever you plugged in 4, 8? 52. So, to find the max and the min, don't overcomplicate this. The max is the largest number. The minimum is the smallest number. So, Josh, what is the maximum on this? 52. Always take note as to which point gave you that. So, what point gave us that, Josh?
4, 8.
4, 8. Okay. Miss Williams, what was the minimum?
8.
What point gave us that?
1.
Questions on that? On how to use the points and the objective function? Okay, going to example 4. So on this one, it gives us everything, all the equations that we need. And now we're going to go through that whole process. We'll graph the constraints. We'll find the feasible region, locate the vertices, plug those into the objective function. All right, it is a long process, but I don't think any one step is necessarily difficult. All right, so on my first equation, I'm going to find the x-intercept. So that means I'm just going to ignore the y term. And it's x equals 6. There's no math to be done because x does not have a coefficient. My y-intercept is going to be the same. Ignore the x term, so it's y equals 6. And then go ahead and graph that line. There is 0, 6, 6, 0. Connect the 2. Then do the same with the second equation. I ignore my y term. So now I've got 2x equals 8. So what is my x-intercept? 4. 8 divided by 2 would give me 4. And then my y would be 0, 8. So I'll come over here and graph those. For 0, 0, 8. Connect the 2. And then I've got the two straight lines. So I've got x equals 5 Then I have y equals 0. Y equals 0 is just along the x-axis. We don't necessarily have to graph that one, but that is where that would be. So, let's go through here and shade. So the first one, the 0, 6, 6, 0. The sign is less than, so am I going to shade above or below? Above. I'm going to go opposite the sign, opposite the way you think you might shade it. Okay. The next one is greater than. So am I going to shade above or below that line? Below. So it's just going to be that little corner area. X is less than 5. Am I going to shade to the left or to the right?
Right.
To the right, which is just the only part that is unshaded. And I'll do this one in a different color just so you can see it. It's just this little corner down here. That's the only part that was left unshaded. So next we need to do what, Trey? Once we have it all graphed and all shaded, find the vertices. How many vertices are there on this one? 4. 1, there's 3 of them down here. Okay, 1, 2, 3. Zoe, give me 2 of those vertices.
2, 3,
Okay,
and 4, 0.
awesome.
Oh, yeah.
2, 3 or 2, 4. Sorry, 2, 4. Garrett, what are the other 2?
5, 0.
Okay, and?
1.
So next is the tedious part of plugging all 4 of those into that equation. Alright, Andy, whenever you plugged 2, 4 in, what did you get?
26.
Chance, whenever you plugged 4, 0 in, what did you get? Joe, 5, 0?
15.
And Isaac, 5, 1? So Zach, what is the maximum?
26.
From what ordered pair?
2, 4.
Minimum?
12.
From?
4, 0.
Questions on that process? Because on the back, everything's going to be the same on the back except all those equations, all the constraints. We will have to come up with everything. The objective function, so having to write equations given a word problem, which I know a lot of you love to do, and you spend the majority of your weekends doing that.